In this video I will show you how we can use an electroscope to detect a charged object, whether a charge has an object or not. So this is an electroscope, and this is made from metal. So this part over here is metal, and it is metal all the way from here all the way to the bottom, and these are the two leaves, if you want. This is what we call them. So these two pieces are very light, and they're simply hanging down on the electroscope. And I have another electroscope over here. Now what I'm gonna do, I will bring, let's say, I bring a PVC rod. This is my rod, and let's say that I have charged it. I will make my rod to have a negative charge. So, and I'm drawing, I do want to point out, I'm drawing these minus signs outside of the object to indicate that these are on the surface. So these are surface charges. Okay, they are not in the interior, they are on the surface. Now this is what happens when I bring this this charged object near the electroscope, which includes metal. What happens? These electrons will repel the electrons that are present in the metal. Okay, and because a metal is a conductor, we know that they include electrons free to go anywhere inside the object. So because of the presence of these excess electrons here, the electrons free to move in this material, in this object, will go as far away as possible because they feel the repulsive force from here. So any mobile electron around this part of the object will end up shifting here. And because I have removed some of the electrons from this part of the metal and I have moved them here, this will leave some excess positive charges on this part of the electroscope. Now I made, let's say, five minus signs, so I need 10 to make it neutral. I need one more. Okay, 3, 4, 5, and then 3, 4, 5 with the 10 minus signs here. Overall, my electroscope is neutral, which is what I started with. But there is a separation of charge. Now I have some positive charges here and some negative charges here. Now what happens is, because these two leaves, as I call them, so this is, okay, this is one leaf and this is the other leaf over here. Because these are very light and now they have an excess negative charge, we know that electrons repel electrons, which means this negatively charged leaf will now repel the other negatively charged leaf. And what will happen? We're gonna see those two leaves actually moving away from each other. And this is due to the repulsion between the electrons here and the electrons there. Now, if you have another electroscope and you bring, say I bring a rod that has no charge on it, nothing will happen. Typically, I don't draw that, but I will show you here. Any electrons are gonna stay where they are, and there will not be an accumulation of negative charges anywhere. It will always be balanced by the positive charges, and the same thing here. There is no separation of charge. Any electron will be balanced by a corresponding positive charge. So there is no, and the same thing everywhere. Typically though, okay, this is not something that you have to do. I'm just drawing these pluses and minuses to show you that there is a charge balance. Since the whole thing is electrically neutral and every mobile electron is around a positive charge that counteracts the negative charge, the two leaves, they will not exert a force on each other. They will not repel. So when you bring a neutral object near an electroscope, you should not see any motion on the two leaves. Those two should not move. Now, what happens if you end up having a rod, a piece that has a positive charge instead of the excess electrons here? Well, instead of, if this was plus, then you would be attracting the mobile electrons close to you. So here all of these would be minus signs and all of these would be plus signs, and they would still repel because they have the same kind of charge, positive, positive. So if this was a positively charged object, you would still see the repulsion. The two leaves would be moving away from each other, but that's because they both have a positive charge. At the end of the day, anytime you have a charged object, if you bring it near an electroscope, you will detect that the leaves move, and that's your indication that your object is charged.